Okay, welcome everybody. We're already live recording. Today we will be covering the first technical lecture. We'll be speaking about HTML, CSS, SVG, and if we have time, we'll be also covering some basics. If you want to follow along, this is all interactive. Like all of these, except for the Git part. All of the web-based stuff, you can actually try out stuff directly. If you go to dataviscourse.net/tutorials, let me share my screen. So now you should be seeing my my browser, and this is the website dataviscourse.net/tutorials, and then you can just follow along by these different sections. So I'll be doing this offline because it might be a little faster occasionally, but this is the same thing as you'll find. So first, is the text big enough? Can everybody read my screen? Looks good. Great. Okay, let's get started. So the very basic language, since we'll be doing data visualization on the web, that means we'll have to deal with HTML, we have to deal with CSS, we have to deal with JavaScript, and then with this library that's called D3. But the very basic and the oldest technology around is HTML, and HTML stands for Hypertext Markup Language. And so in this module, we'll go over the basics of the content of how is a web page rendered in HTML. And so 25 years ago, HTML was really meant for documents. So you kind of said, hey, this is a heading, this is bold, this is kind of a link with hyperlinks. But nowadays, it's really HTML5, the latest standard, has evolved so much. We can now, as we know it, with all kinds of graphics, audio, video, but most importantly, web applications, right? We don't websites are not just documents anymore. They are more and more becoming the applications where we do most of our work. But even when I was an undergraduate, this wasn't the case, right? You could barely make interactive web applications. You could with some Java. And of course, JavaScript was around already, but it wasn't quite as common as it is today. So I'm assuming that a lot of you have already heard about HTML. Some of you might have taken the use web development class. So this is going to be a recap, but just also be aware that there's a lot of students from other departments in this class. And so just be a little patient if you've seen this before. But I'm sure there will be some interesting nuggets about CSS and SVG that even if you've taken the web class, you might not have heard before. Okay, so it's made up of text, and that text is then interpreted by the browser and rendered on a screen. And what constitutes an HTML page is kind of these elements. So this here is the most simple example. Here we have an element that encloses a text, a single sentence. This is the sentences. This is an HTML element, and it's enclosed by these element tags. And these tags tell the browser, well, please render this strong. So for example, if we were to change this to italics, the browser would now interpret this as please render this as an italic element. And so these elements is kind of we can nest them, we can create more complex versions of them, and this is kind of how HTML works. And so notice that we have an open tag and closing tag, and then content of that tag, and this content can be text or it can be other HTML, and so we can just nested stuff. We can have these closing elements strong and closing strong as we had just before, but we can also have self-closing elements. So for example, BR is breaking a line is something that you don't really need to open or close. You just say BR. Similarly, if you want to include an image, you would use the image tag, which doesn't, where you don't really need a closing tag. So you would rather work with the image tag and then add attributes. I'll talk about more what these are later. But until a couple of years ago, this wasn't actually legal to just say break or image. but you had to be like, you had to do this here. Like this would be like proper HTML like 6 or 7 years ago. And then the alternative would be to have these self-closing notations. You still see that sometimes. I used to do that like even 4 years ago or 3 years ago. But now it used to be an XML, like basically HTML used to be XML, and XML is this markup language. It's more specific, or the more general like idea of like how we store data. But HTML5 is no longer an XML-based language, and so we don't have this enforcement of opening and closing tags, and so we can have simple things like image and BR break without having to like worry about closing tags. By the way, if you have any questions, like just type them into Slack, type them into the chat, or just speak up, and then Devin will be moderating if he sees any text comments.
Do you still need to do the closing if you're doing XHTML?
Yes, you do have to do that. So this is kind of like when you still basically use the XML standard, then you still have to use the closing tags. So otherwise, like your browser is going to run invalid. Okay. HTML elements can and do nest. So as I mentioned earlier, I can have like a strong element, and in that strong element, I can have
Lucy, leave it. Sorry.
Okay, no worries. So we can have these nested element, and this is going to be super common, right? We'll have deep hierarchies of HTML. And then where it gets interesting is we can have attributes. In addition to content within the elements, like we have here, we can specify attributes of the elements. And so A here is an anchor tag, which is kind of like actually a link. And href is a hyperreference, and this is like where this link is going to point to. And what we get here is a link to the School of Computing, and this behaves just like a link that we would expect on the end. However, my mouse changes. If I click on it, I'll go there. And so there's many different different attributes for these that are specific to the individual elements. The other thing that you could, like another example of an attribute would be this title attribute. And the title attribute, essentially, if you're on a desktop computer, you can hover over an element that has a title attribute, and then you can see the tooltip. And so here you see the more information on hover tooltip. Why? Because I hovered over this title attribute. And that's also a useful technique in visualization. So I see we have a hand raised by Garrett.
Yeah, I had a question. I've only actually ever seen anchors used for hyperlinks. Is there another use for them, or what else are they used for?
So like it's called anchor because back in the day it was meant to be like internal navigation of a website as well. So you would specify them with an anchor. This has been kind of like changed. Nowadays you specify internal links with IDs, and then you use an A element to point to them. So nowadays, A's are really just links. It's just historically, they used to be a little bit more versatile.
Great, thank you.
Sure. Okay, so some other super important attributes that we'll be covering are ID, class, and style. And so we'll cover, talk mostly about this when we talk about CSS. So the ID attributes gives an attribute a unique identifier on a page. Like here is a, let's see, no, I don't actually have an example here. Anyways, an ID attribute gives an element a unique identifier. And as you can imagine, this isn't all that important if I write HTML. I don't really need unique identifiers. But if I were to, let's say, programmatically manipulate my HTML, it's quite important. This is kind of like your variable name, right? So this is like how you specify an element that you maybe want to later access with JavaScript. A class attribute is useful because we can kind of like say all of these paragraph elements, I want to all treat them to be of the same class. And then we could, for example, do unified styling. And then the style attribute would allow us to like actually apply styles to what we're doing. So what I've done here, like what you nowadays, like, so for example, you can still do some styling in HTML, but typically people, it's very much encouraged to kind of separate content from styling nowadays. And so you really want to specify all of your styles in CSS. And that allows you essentially to also flexibly style your elements depending on like what platform you deliver your website to. And it's also especially useful for things like screen readers and so on, that you have the semantic information, like what is actually going on the website in the HTML elements, but you don't like bog down the whole site with styles by using inline styling or by using styling as part of HTML attributes, which sometimes you still can do. Okay, great. So here, like, I'll just go over quickly a couple of generic HTML elements. So first, what we'll see is like this here is a full valid HTML page. This is what it renders. It includes like headings and it includes an image. But what I first wanted to talk about briefly is this like boilerplate here. So we see like every HTML document has to start with that. And then you have like your HTML declaration, then you have a head. In the head, you give some information. For example, the character set is UTF-8, which is our character encoding that we're using here. Then the title would be what's rendered here in this browser tab. So I can kind of like, for all of these examples, you can always open them up in a new page. And so here you see the title tag at the top as HTML demo.
Hey, Professor.
Yeah.
Sorry to interrupt, but I've been hearing you kind of intermittently break out every once in a while, or cut out. And I asked on the chat, it sounds like a bunch of other people are experiencing that as well, just for like 3 or 4 seconds at a time. So maybe like pop your Wi-Fi off for a second, turn it back on, or I don't know, something.
Yeah, that's going to be, well, if I do that, I'll for the stream will go offline. Is it still bad?
Yeah, it just happened while you were working on that.
Okay. Maybe what we can try is that there is a video off. Maybe that kind of like reduces my bandwidth a little bit.
Yeah, someone in the chat saying take off your camera.
If it doesn't get better in 2 or 3 minutes, I'll yeah, so I'll turn my camera off as well, so that changes. So is that any better now?
So far, yes.
I'll keep going, and please interrupt me if it doesn't work. Then we'll do like a bigger reboot. Okay, so different HTML elements. We were talking about metadata. Here we have kind of like the head, and then we'll see that, for example, links and so on go in here. I'll show you an example later. This is the title page. And then we have the body, and this is what actually is visible. So here we have a paragraph element. Fairly simple, a paragraph with a self-closing break or just a regular break as I showed it earlier. Here's how I specify an image. I say like image tag source. And then to be valid HTML, you also have to provide an alt tag, which is basically the textual description of the image. And then here we have headings. So H1 is heading of level 1, H2 is heading of level 2, and then we have H3 and H4 and so on. We can also do comments in HTML. So this would be like you have to use the syntax here with the exclamation mark, the point and the 2 dashes, and then closing it with the 2 dashes and the tag sign. And so that's, of course, as in any programming language, quite useful. So this is all fairly basic. This is what this looks like. Just to review some of the metadata attributes, we have also things like script tags, which will go into the header here. And in the script tags is where we actually specify, either directly specify our JavaScript, or we can say we link to a JavaScript file, either with the within one of these tags here. So this is how we can bring in more The link is also useful for including CSS files. So if you have a bigger project, you probably want to separate your styling file from your HTML because you might want to use your styling in multiple pages. And this is how you would include that. If you want to specify lists and tables, this is how that goes. You have like OL for ordered lists. So this is like the ordered list here. The numbers are automatic. And then unordered list here for you specify this by the INUL element, and then these nested LI elements. And then tables are specified by like the table tag. And as I said earlier, like I'm doing the border here, but that's usually something that you don't want to do. This is like HTML-based styling. You would rather do CSS-based styling. But just for like brevity here, I'm doing the border because we want to see the table here. And then a table is made up of rows and columns. And the rows are specified as TR, table rows. And then the cells in these rows, like there's two different types. There's the TH, which are the header cells, and then TD is table data. These are like the content of these cells. So fairly simple. One thing that you frequently want to do if you're structuring an HTML page is you want to use these divs frequently because divs are divisions of a page. And so if you have some kind of like group of things that belong together, you usually pack them in a div. And so divs are super common and provide structure to a lot of elements. And then you can later like lay them out and style them if you want them. And very similar to the div is a span. The difference is that a span works inline versus a div breaks a line. So if you look here, this div here, the div tag, the division of a page, that's its own line here. And so this, like the next div is in a separate line, but the spans here, they are one single line. And so spans, you can use them as divs, but you would use them if you don't want to have like essentially like a broken up element, but you rather want to have an inline element. And then the last elements that I want to talk about are forms. Forms, kind of like you can specify data that goes into a form with a form tag. And then you have different input types. And so here I'm showing you like a text box, a large text area, and then a slider like this. And then finally, I have a submit button. Is my audio still okay?
Sounds a lot better. A little bit, but it's a lot better.
Okay. Great. So and so these different input types here, we have the text is like the text field here. Then we have text area. That's this piece here. And then we have a range here for that slider. And then I have like attributes. For example, for the slider, I have a min and the max attribute. I give it a name. I have an ID, and so on. So all of these things. And then when you submit, you can then later programmatically handle the submission. You can define an event that happens on submission and so on. But we don't have to deal with this today. This is when we'll talk about JavaScript. Okay, I did mention this before. And so here's like a piece of necessary boilerplate that you have to include whenever you create an HTML document. I will not like it's kind of like a lot of lines here, and I'll kind of sometimes have that included in the examples, but sometimes I'll just do the do only the core stuff, and but in reality you would actually have to surround every HTML page with this kind of boilerplate. Okay, so this was kind of like the very brief introduction into HTML. Now I want to talk a little bit about the document object model. And so these two things are very related, but the document object model is kind of like, if you have a static page, you can think of the HTML that you write as very similar to what's going on in the browser. But in practice, the DOM is actually like this tree that is created by the web browser to present the document, but it's also an API that the browser provides that we can use to access the elements on the page. And so the way we kind of can look at the DOM is by looking, like using the inspector in like a browser, like Chrome, for example, has a nice inspector, but all other browsers do have an inspector as well. And so you can either like do that by right-clicking and say inspect element, or you can go to view developer, inspect elements, or developer tools. And so this here is what you're actually seeing. And let's do like a simple page here. I'll open up the inspector, and you can see you can actually browse through the elements. And this is actually the whole DOM here, and you can see this is exactly what we wrote. But I also have style information down here, and I can modify that, and we'll play with this later. And then we have the console, which gives us like error messages, or where we can execute JavaScript, and so on. And what's neat about this is that we can like hover over these elements. Like this is maybe more interesting in a complex example. So here I could say inspect this element, and it would automatically drop me into that, which seems kind of trivial. But if you're like later generating the DOM dynamically with JavaScript, this is the way to see what you're actually writing, right? You kind of like see something in the screen, you right-click it, and then you see like this is actually what's going on here. So here's a link. Like the developer tools can do more sophisticated things. For example, they can do like performance profiling and so on. So definitely like a valuable resource. Okay, any questions about HTML before I move on to CSS? Seems like we're good. Great. So CSS are kind of like the how we make things look good on the web, cascading style sheets. And one thing that is like, I'm going to give you a small subset, and you should look at the MDN CSS website. By the way, MDN is generally the Mozilla Developer Network. Web docs are kind of like the best reference on the web. And so whenever you want to look something up, like what is this, what attributes does this element have, or what are the elements that are available, I strongly recommend MDN web docs. I strongly not recommend this. If you Google, let's say H1 HTML, the first hit is usually the W3 schools, and they've been terrible. They have gotten a little bit better, but the MDN is like very authoritative and is very detailed, and is kind of like also technical. So for like a software engineer, this is like the right website. Okay, so CSS is about styling, but CSS also has what's called selectors, and this is kind of like what we mostly care about, because we want to use those selectors later to use JavaScript to access elements and to modify elements. And so we'll be learning about both how do we style something, but mostly it's really about like how can we select different elements on the screen. And so here is like a simple example. I have my style file defined within the head. And then here I'm saying, hey, to the strong elements, apply these certain style attributes. Say background color is this red thing here. Font size is 150 compared to what you would usually render. And then we can use like, this is an element level selector. So this applies to all elements of type strong. And we know that this is an element level selector because it doesn't have any other, it doesn't have like, well, this would be a class selector. This would be an ID selector. And this, the element selector simply has no additional kind of like syntax here. So this is the strong element, and you can see that this strong element here, this background color and the font size here is applied. Okay, so what you need to know is that CSS rules apply in the order that they appear in a document. And if more than one rule match the element, then both of them apply. There's a little bit more nuance, which we'll cover later, but for now, this is okay. For example, this here, where we have those two lines in one strong element, are essentially the same as this here. In practice, of course, for this example, the other one is more succinct and therefore preferred, but there can be cases where you want to like where you have different selectors that apply to the same element, and then they are applied in order. And so you see that this looks exactly the same as the one before. Okay, so now we've done element selectors. Now let's look at class selectors. And class selectors are identified by this leading period. So for example, dot important. So notice that they are here, they're identified with dot important, but here there's no dot, right? This is like class is important, no dot. The dot is kind of like this type of attribute that we are matching to here.
We have one question on custom elements, basically if it's possible to make your own HTML elements.
That's a good question. I think you can now, but that's a fairly new thing, and I don't actually know the answer.
I can help a little. You can do that inside of specific frameworks, just by kind of denoting exactly what you want to do. They're usually called directives, but yeah.
Yeah, but that's then like probably parsed and converted to something else, right? So it's not actually creating your own HTML elements.
That's true. That's true.
A question about CSS. Earlier when you're saying that basically they are evaluated in like the order that they appear.
Yep.
I'm not super familiar with CSS, but I thought there was like a hierarchy to them, like classes applied over IDs, which are applied over. Exactly.
So that's why I said this is like I'm going to go into detail about this later.
Okay, great.
Yep. Or well, not all that much detail, but yes, you're right. There's rules about. Are we all still here? Because I just lost the Zoom screen.
I can still hear you.
Okay. That's weird. Anyways, you can still see my screen too?
Correct.
Yep.
Okay. Yeah, so yes, there's rules. If you have conflicting declarations, there is a hierarchy, and this is documented, but it's pretty messy. So you kind of want to avoid that. You want to have like unique definitions, and this is like a source of problems more than an elegant feature. Okay, any other questions?
Yeah, I have a question. Like when you try to define those strong in the CSS, like can some of those attributes like override the previous like definition sort of?
Yes. So if I were to say have well, I can try it. We do background color, and then we do background color and say blue. Not safe. And now you see that I have actually overwritten this. So now I have a definition that is basically this one here is useless because it's been overwritten by this one. Okay. So CSS class selectors. So here I have an example with two class selectors, important and footnote. And then here's there are three divs. One is important, the other one is footnote, and the third one has both important and footnote as class. So it's absolutely legal to have multiple class attributes for a single element. And you can see the result of that. Important is bold. Footnote, I have reduced the size to 75%. Maybe let's make it even smaller. So you see that there is a big difference. You see that like the important applies to the first one, the footnote applies to the second one, and both important and footnote apply to the third one. So this is small and bold. Very similar to CSS, sorry, my Zoom is acting up here. Very similar to the class selectors, the ID selectors. The one big difference is that IDs is you should use IDs as like a variable name for individual elements. So you should not reuse an ID element ever. An ID element should be absolutely unique on your website. You can think of it as a global variable. And this, you should, of course, not define two global variables with the same name. You can do it, your browser will still render it, but it will lead to undefined behavior when you later use this property. So the IDs are like you access them from CSS with the pound sign. So pound first line here is this example. I have 3 different divs again, first line, second line, and important. And so this looks exactly like the class definition, but that we are using the ID attribute and the pound sign here instead of the dot and the class attribute. But as I said, this should be like a unique value. You can, again, it's okay to give 2 names to one specific element, but typically, well, there might be situations, but I can't really think of one where that would be desirable. You can also use these ID elements as these anchors that I mentioned earlier, where we had this question of what did elements, what did these anchor, why is it anchor and not link? And so what you can do now is like here, this link, if I open up this link here, it will drop me into this website, but it scroll exactly to that ID and to that element with that ID. And that in the URL is highlighted with like pound and then CSS ID selectors, right? And if you look at the website, like here, I'm looking at this heading here, I'm going inspect element, and then I can see H3 has ID, CSS, ID selectors. And now I could actually like write my own link that links directly to that particular section on the website by just like adding this with hashtag CSS-ID-selectors to the URL. Okay, so for styling, they work just as class attributes, but yeah, well, there's nothing like special about them when you use it for styling. But of course, it's not as commonly used for styling because it applies only to a single element as opposed to like a group of elements. So you can also use, for example, IDs and CSS to create layouts. So here would be like a simple layout for a page. Like I would have a menu on the side, and I'm showing this in blue here, light blue here. Then I have a main part of the page with content. And then I have a green footer here. And this here isn't actually specified, like how this is laid out, isn't actually specified in the HTML, right? You see simply here I have a nav element, which is a navigation element. And it acts more or less like a div. Then I have a main element, is again acts more or less like a div. It's just called main so that like we know semantically that this is the main content. And then I have a footer element, again, same thing, acts like a div, but semantically we know that this is a footer. And I don't actually specify how these are placed. And I specify how they are placed and how much width and height they take up in CSS here. And then I could do like things like media specific queries, look at via screen size. If you have like a small screen, like in a phone, you wouldn't use the sidebar visibly. You would do that as a modal dialog or something like that. So that's kind of like possible. I should say that this is kind of like a little bit of an outdated way of doing that. You would rather nowadays use something like CSS grid layouts or some kind of other CSS framework that are a little bit more advanced to let you do a layout. But the point of this really here is to just like show the CSS that you can do these kinds of things with CSS, and you can use IDs to specify these different areas of your page. Okay, a little bit more advanced are CSS relationship selectors. So CSS lets you match elements based on their relationship with other elements. There is like more detail on the MDN website about this, but I want to show you two, the child selector and the descendant selector. So this is how the child selector works. And this is how the descendant selector works. So the child selector says, apply whatever is happening in here to all bold elements that are a direct child of a P element. So it has to be direct. It can't be another level of nesting. All the B elements that are directly in P are shown in blue here. And so here we have an example, a bold element that is nested inside a P element, and this is what this blue here corresponds to. Similarly, but slightly different, is the descendant selector. So here now I say div B and apply color green to it. no symbol in between, and that means any kind of nesting between like wherever a B is nested within a div, no matter what is in between, apply that to it. And so here is an example. I have like a div, then I have a span, and then I have a B. And this wouldn't match if I had like a div, like a child selector, then that wouldn't work. But because I have like a descendant selector, I can see that this bold text here is actually rendered as green because of the descendant selector. Any questions about this so far? Okay. So this is like what I earlier said. If you have multiple rules that match, maybe conflicting rules, then it gets complicated. There are rules about which is the most specific element that applies, but in practice this is not intuitive. And so like usually what you want to do if some CSS doesn't take is you want to like start looking at like what is going on in the developer console. And so it's pretty nice that I can do things here. For example, if I, let's say, inspected this element here, I select this, I can see exactly post content H3 has a font size of 26. And now I can actually turn off the font size. I can dynamically change that. Or I can say, hey, I want like font size 76, right? Or if something is struck out, you can see that it has been overwritten by something else. So this doesn't take. So if you, for example, apply some kind of styling and it just doesn't show up, open up the console developer, the developer tools, and then you see if it's struck out, then something else is applying here. And you can also write new stuff in here. So you can kind of like try out CSS dynamically as you want. And you can just like switch off individual elements. So I can kind of like really modify the whole page and like by simply apply or changing the CSS dynamically in the developer tools here.
I had a question.
Sure.
In the developer tools, there's like a dot post content, and then it has the child selector with a star. It's like the third one down. Does that star just mean like just everything under post content, all children under post content?
Probably. That's a good question, but I'm assuming we can just see what it does. It's a little hard to see, but I assume that's correct. Yeah.
Oh, okay, thank you.
Sure. Okay, where am I now? Oh yeah. So let me reload this page because I've screwed up the layout. Okay, so one other thing, like what we've so far used classes and IDs and elements as selectors, but there are also pseudo classes. And pseudo classes are selectors for states that can be combined with other selectors. Like your typical example is a hover or a visited, but you can also do some more advanced ones like the nth child. And so let me first show you what this does. Here, the hover essentially says, if I hover my mouse over this element, then apply that particular style that I define in this hover pseudo class. And then here I have like have a pseudo class for when a link is visited, render it in green. And then here I'm using this nth child selector. So I'll first like talk about those two and then talk about the nth child. So this is fairly simple. I have like a class definition with .hoverable, and you see that I am applying this to the span here, say class.hoverable. And then for like, if it's not hovered, I'm simply doing this here. But if it also matches the pseudo class hover, then I'm also adding this background color. And similarly for heading 2s, I'm adding a hover with a different background color. So, well, do I have a heading 2? Yeah. Where's the heading 2? Yeah. We can also hover over an element here. So this is kind of like the element definition. So I don't have a class definition here. I'm just saying for all H2s on hover, change the CSS accordingly. And I can do the same thing for like a visited link. So here I would have like if I didn't have that here, you would see that, let's say, take that out. You would see that this here goes back to the default like violet here. But if I add that back in, if I added in the color again, it would kind of like apply on a visited link, but only if I've actually visited it. Okay, so finally the nth child, and this is just an example that you can do some more interesting things in CSS as well. So here I have a list element and then a match on every nth child. And here I would just say the first one. And for the first one, I want to apply this blue. And this is what's happening here. Like I'm essentially saying the first element in this list, like of these four, there's no specific styling in these lists, right? This is just like what I'm doing with these pseudo classes. The first element here is shown as blue. And then I'm doing this nth child with 2 n. So every second element here, the n, it gets this coral background color. And that's, of course, useful for things like lists or tables where I want to have like every other row, I want to style it specifically. And so that's like a nice and elegant way to do this with CSS. You can, like what we've done so far is we've kind of like always used the style tag in the heading to specify the CSS. There's 2 other ways of specifying CSS. One very common is to have an external CSS file that like you simply link to in your header. Or you can do direct inline styling. So for example, here I'm saying B style color is steel blue. And that's, of course, like doesn't really like transfer well between, let's say, different bold elements that I also want to show in steel blue. And so if you would write HTML, this would be something that is fairly unusual to write. But if you later modify and add the style tag here with JavaScript, that might not be all that unusual, that your like DOM that you have here eventually looks like something like that. OK. Any questions about CSS before we move on to SVG?
So I have a question about the nth child command. So say if we'd included another unordered list in the document, would it also apply to that other unordered list, or would it just apply to like, basically does the nth child, does it apply only to the first?
No, it will apply to all unordered lists unless I make it more specific, right? So here, I have a second list now. And it applies. But if I say UL class is first, then I can do here, I could do instead of Lee, I could do dot first and then dot first here. And then it should only, well, it actually doesn't apply at all. Haha. That's the perils of live demos. Let's see. Well,
you answered the question though already, so I appreciate it.
Yeah. I'm assuming this is because I would have to do it on the list elements, not on the UL. So that's the problem. And I would need to do this for all of the of these elements here. Let's see whether that actually fixes it. And if it doesn't, I'm going to not try further and look it up later. Yep, that's it.
Okay, thanks. That makes sense.
So there's another
question.
Garrett?
Yeah. So I don't understand exactly why there's like a ID and a class when it seems like they're kind of doing the same thing.
Yeah, they're not really. Like think of it as let's suppose I have like one submit button on my page. I want to uniquely be able to identify that one submit button. But then I might have like 15 paragraphs on my page, right? And I want to style those 15 paragraphs in a special way. And so for like if I want to style those paragraphs, I want to use a class. But if I want to identify a unique element, then I want to identify, use an ID. And this is going to be important. For example, if I have, let's say, if you build a visualization, you will have an SVG element that contains all of your subsequent like SVG code. And if you then want to modify this with JavaScript, you want to say, give me this one particular SVG element that has my visualization that I'm working on in it. And you don't want to say, give me all SVG elements of a certain type. Does that make sense?
Yeah. I kind of got when you were saying that earlier. I guess my question is, if you just created a class that said submit button, and there's only one button on the page.
Well, it's always good principle in software engineering to be explicit about what you mean. So technically, they might not be the same, or they might be very similar. They're not. There's differences also technically, but you could use like you could say, hey, I'm using this div, like I'm using this class element only once, and I'm doing this by convention. But then if somebody else looks at your code, they would say, hey, like this is a class element. I'm not assuming that you're trying to do this one time, and if they're modifying your code, they would reuse that class element, and then you have troubles. And so this is as much about kind of like communicating, like, or just convention and understanding what's going on, as it is about the technical implementation.
Great, thank you.
Okay. Let's move on then to SVG. Okay, so SVG is kind of like how we create visualizations on the web, or how we frequently create visualizations on the web. SVGs are scalable vector graphics, is what it stands for. And that kind of already implies it's a vector graphic, not a pixel graphic. Like, for example, that would be also the difference between a PNG file and an Illustrator, Adobe Illustrator file. The one is a vector graphic, the other one is a pixel graphic. And so that means that we can kind of like scale it as in a name without the loss of quality. And so SVG is a very popular way of doing visualizations on the web, but there's other ways of doing visualizations on the web. You can do some basic visualization stuff just with vanilla HTML without SVG, or you can use these other two kind of like libraries, or let's say APIs. That's the Canvas API and the Webgl API. They have very different purposes. Canvas is a raster, like a pixel-based API, and Webgl is kind of like mostly for 3D. So you have like the capabilities of doing like even things like games in your browser with Webgl, 3D games. And both of them are useful in visualization. Canvas is often faster than SVG, and Webgl is probably even faster, but I guess technical hurdles and other downsides kind of increase as you like move to Webgl via Canvas. We unfortunately, since we kind of need to keep it a little bit simple, we will just stick to SVG, but it's also not uncommon to combine SVG and Canvas in visualization projects if you, for example, have some high performance rendering needs or something like that. Okay, so here's like a minimal SVG example with valid HTML boilerplate. And this isn't all that exciting because it just renders an empty SVG. But if we like open this in a new page, let me close this stuff here. If you open this in a new page and inspect your element, you will see that the SVG is actually in here. And so, well, you can see that there is an SVG element, not that interesting. So now let's draw the first thing. We can draw a circle. And there's always links here to the documentation of the particular element of SVG. You can just click on it and then look at the MDN documentation. So a circle has an X and the Y position, and this specifies the center of the circle. And then you also have a radius. And one thing that I'll be doing going forward, I'll just keep this nice and clean and not use all of these HTML boilerplate, even though it technically, if I open this up in a separate page, is not valid HTML, but it still works, and it just keeps it like more focused. So here we have an SVG. I have to specify width and height in pixels. And then I have my circle. I say CX, CY, so center X, center Y is 200 to the right, 100 down, radius of 50. And then I'm using the style properties here to say fill it gray, stroke it steel blue, stroke width to 5 pixels. And that's our first SVG like drawing that we've made. So fairly simple so far. Seems easy. One thing to immediately note here, as I already said, is that the coordinate system in SVG originates from the top left, which is kind of like common in computer graphics, but not so common if we think about data analysis. So here, if we have a scatter plot, we would usually assume that we start in the bottom left corner. So that's usually what you would have to adjust for that when you implement that. So here is like simple example that shows these points are 10, 10, 40, 40, 70, 70, and you see that they like go downwards. So this is the SVG coordinate system. Dimensions here are given in user units, which by default matches to pixels. But of course, pixels nowadays with retina displays and so on, they are kind of like a weird concept, but usually it works relatively fine. Okay, so one thing that you might have noticed that I have controlled some appearance aspects by attributes such as position and size, but others like color and weight by CSS properties. Like here, like positioning, well, this here is a good better example. Here I've positioned and scaled it with SVG attributes that are unique to Circle, but then I've applied these stylings here with CSS-like syntax. And so it is kind of confusing because I can sometimes do both. So for example, here, I don't use any of these style attributes, but use these use direct attributes of the circle element, and I get the same result. I can say fill is gray, stroke is steel blue, stroke width is 5 pixels. Same result. Interestingly, though, that it's what is applied if you specify both, it's actually that the presentation attributes are applied, which is kind of confusing. But well, it's actually in HTML especially, it's the other way around. And the next confusing bit is also that some of these things here, like for example, fill, there's a similar concept in HTML. So here, like I'm showing you a rectangle and a square and a circle, and this rectangle here looks exactly the same, but this here is rendered as like a regular HTML div. So this is not SVG. The circle here is rendered as SVG. And so how I specify these styling attributes is unfortunately completely different. So first I say like width and height, which is kind of like an attribute of the circle here as a style element. Then I'd say background color instead of fill in HTML. Then I say like border style solid for stroke, and then border color for like again stroke. So I have to actually say this is a solid border in HTML. I don't have to say that in SVG. So basically, what I'm saying here is if you ever look for styling specifications for SVG, just be absolutely sure that you're actually looking at style definitions for SVG, and don't assume that you can translate CSS styles for HTML to CSS style for SVG. And why is that the case? The reason is very likely historical, that those two standards developed independently, but it is unfortunate, and it is a source of confusion. Okay, so let's look over some other kind of like geometric shapes here. An ellipse I specified by position, a radius in X and a radius in Y. So position is CX, CY, radius in X, radius in Y. Again, I'm using my styling here. So fairly simple. Rectangles are specified with an X, a Y, a width, and a height. So here I have a rectangle at 50-50 with width 200 and height 100. So if I change this to 200, my rectangle changes. Now it actually is cut off here because my SVG isn't big enough. So I would need to make my SVG bigger, and then I can actually see the whole rectangle.
I had a question.
Sure.
Does the X and Y does the X and Y actually specify like the left top corner of the square, or does it specify the very center of the square?
It specifies the top left corner.
Oh, okay. Okay, thank
So
you.
if I go to 0, 0, you can see that it's kind of like snug in the top center. Yeah, the center would be an alternative, but that's tricky then. Like in many cases, it's just easier to have like the point closest to the origin in the coordinate system being the thing that you move.
Troy also
sorry,
has
but-
a question in regards to specifying in pixels and especially different screens,
Yeah.
you know, having render displays, I suppose.
So this is a complicated subject, but essentially, when we talk in HTML, when we say pixel, we don't actually mean pixel. Operating systems even don't expose that anymore like that directly. So it's more of like a unit that we kind of agreed somewhere in the 2000s is roughly a pixel. Does that make sense? So pixels are just something that think of it as a unit that you're somewhat familiar with, and usually if you're like on the range of 800 to 1600, you like will see that on a screen. That's actually like the most useful way to think about it nowadays. It is like very with super high resolution displays and 4K and so on. All of the websites wouldn't really render anymore if I had hard pixel specifications. So if I had like a 800 pixel specification from a whole width website, and suddenly I have a 4000 pixel display, it would barely be visible. So that's why this abstraction happens. But this is on the operating system browser level. You actually don't have to worry about that too much. You can specify, like SVG has to be specified with pixels here, but you can modify that dynamically. And yeah, so it's not a big deal actually, or it's not difficult in practice. Okay.
So I have a quick question.
Sure.
So for that little border here, like is that because the SVG or the canvas position?
Yeah, this is just where the website that I wrote here to show this that has a little padding in here. So we can look at this in the inspector. So here you see an iframe, and that in the iframe I have my HTML document. Then here I have my body, and the SVG here, like the body, it's the body that has a little bit of margin. So you can see that the body here is margin 8. I can actually modify this directly in here. And then I will actually see it on the very top left corner.
I see. Thank you.
Yeah. So if I were to open this up, I will still have kind of like the same thing. Well, this is actually, yeah, there's a lot of margin here now, but that's probably because I'm not doing a proper HTML specification. I'm just doing this like short SVG. Okay, then lines. Lines are specified using 2 points, x1, y1, x2, y2, with actually that syntax. And so here I have 2 lines, and I have to say a stroke black here, and I'm saying like x1, y1, x2, y2, and I can draw my lines like that. So fairly simple, fairly straightforward. I can also render text in SVG. And for that, I would use the text element. I also, again, position it by X and Y. And then I say some text in this case here. And this isn't floating, right? Like if I had, I really actually have to say where this goes, and I can render those 2 things on top of each other. So this is not like HTML where a paragraph would float around, but the text appears exactly where you say it should appear. And so basically, like you want to programmatically do that in most cases. So and then like the most, let's say, interesting element in SVG is the path element. So this is like how you escape basic shapes. And so I'll show you an example first here is like the shape that we'll be drawing with a path element. Only the blue part. The rest here is just like annotation for me to illustrate like how it's done. And the path element is a polyline. So you essentially specify it using like multiple support points, and then you can also specify like what do you want? Do you want to draw a curve, and what kind of curve? And there's different kinds of curve. So for example, here I'm showing you like 4 commands for like this is basically like a mini programming language. So path here is the attribute. And then I say D, and D is kind of like what is going on, like how do I want to stroke that path? And so here I have my mini programming language to specify my path. And the meaning of these individual elements here is like M1010. Think of it as taking a pen and moving it to position 1010 without actually stroking. Okay, so if you do M, then like you move your cursor to that position. If you say L 5010, then that means draw a line from the position where your cursor was at to this new position at 5010. So that, like, if I had those two here in sequence, I would actually draw a line from 1010 to 5010. Then if I have a Z or a Z here, you would close a path using a straight line to the first point. So in this case, if I just had those 3 things here, I wouldn't actually see it because I would just draw the line again back to the origin. But if I had another thing in here, it would connect back to the origin of that line, of that path. And then C allows us to draw curves, specifically cubic Bezier curves. And there's plenty of different curves. And so I encourage you to look at this stuff in the developer reference. But in practice, for data visualizations, we rarely actually need to manually specify that because it's actually fairly tricky. And we can actually use libraries to generate this. So for example, if I wanted to create a line chart, I would use a path attribute, and I would use a D3 function that generates the path attribute for me based on data. But so now let's look at this example here. I'm drawing here, I'm moving my cursor to 1010. So this is right here. And then I am drawing a line to 5010. So I'm moving over 50 pixels. And I stroke from the origin to that new position. And then I'm drawing to 50-50. Then I'm drawing to 150. Then I'm drawing to 110. And so this is now where I am at. This is what I'm calling like the origin here of the next part where I draw the curve. And so now I'm using a C, which is like a Bezier curve. And now I'm not specifying exactly the points that I'm drawing to, but I'm specifying support points of the Bezier curve. So I'm saying, in this case, my support point here that I'm showing is 1. And note that this red 1 and so on, this is just like stuff that I'm doing down here to show where it is actually, where these support points actually are. So this isn't actually visible as part of the path. So I'm using, this is my support point for that curve. Then here, my second support point for that curve. Here's my third, like this is the terminal point. And so if I were to take this out, I would get, well, nothing. Let's see. I could take this out and then I should get a curve. No. Interesting. So yeah, I probably have to specify, let's see, I can definitely change it. So now I've changed my destination point a little bit, and so I can change the curve like that. So there is a detailed tutorial on MDN. If you're interested in that, I would definitely recommend that you take a look at that. So these are like how you create arbitrary shapes. You can, of course, fill those if you close it. Now let's look a little bit at ordering, because if we draw multiple things, it's also important to know what is appearing on top. And so this is fairly intuitive, but sometimes not very convenient. The order in which elements are drawn is the order in which they appear in the SVG. So here, the first example here, we have an ellipse and then a rectangle. And so therefore, the rectangle here appears on top of the ellipse. And then here we have a rectangle that is specified first, and then the ellipse. And so the ellipse is drawn on top of the rectangle. That seems intuitive, and it is intuitive, but it's sometimes inconvenient because you might be in different places in your code. And then you have to really be very careful about, like, if you want to, let's say, add a label on top of a rectangle, you actually have to make sure that this is like generated in the right order, and you don't have like something like a Z level, like a depth level that you could specify as you would have in something like OpenGL. Okay, does that make sense? Any questions? So then let's move on to grouping and transformations. Grouping is kind of like this very powerful idea that I can, like, you will be using this extensively when we use SVG for actual visualization, because it gives us a level of abstraction, right? So for example, let's suppose I have here, like, I'm trying to create a scatter plot, and I have like a little rectangle here, mostly for something that I want to show later. I'm going to say this is my group. All of these elements belong to the same group. And I can use this as a shortcut. I can say all of the elements in that group are now shown as with a steel blue fill. And so that's convenient. I saved myself a little bit, but I could also achieve that in other ways, right? So this isn't all that important. But the group allows us to do things like transformations, and this is very important. So here I am now saying, take this group and transform it, and then I have another kind of like another mini programming language here, or a specification language, where I can say how I want to transform it. I can translate it, I can scale it, but I can also do fancier stuff such as rotation or shear or anything like that. What I'm doing here is I'm simply saying translate, like, okay, let me give you an example. What I want to do here is I want to create a scatter plot where I can programmatically use intuitive coordinates that I'm starting my coordinate system at the bottom left. So if I want to say like X increases, I want to see this to the right. If Y increases, I want to see that moving up to the top. So I kind of like save myself a little bit of math if I want to show a scatter plot like that. And so I could try to do this with a transform, and this is what I'm doing here. So I'm taking exactly the same code that I have in here, and I'm just applying a different transform, and I'm saying now flip it over, basically I'm saying flip it over, but I have to also specify a translate here. And so in this transform, I'm saying translate, don't do anything in X, move to 200 points to the bottom, and then scale, don't do anything to X, and scale all of the Y attributes, multiply them with -1. And this is exactly what I want to do. So I'm moving this down, and then I'm multiplying all of the Y attributes with -1. And then I'm getting to kind of like basically being able to specify this in a scatterplot style coordinate system without having to do any math in here. So the translate is super useful, and you'll be using this all the time. The scale is a little tricky because it has kind of some negative consequences. For example, if I tried to do this to text, then I would get something like this, text as they read it in Australia. So you have to be careful, like scales and all of these kinds of different things. Not every shape is really like easy to do that with. Okay, so that wraps up my SVG introduction. I'm happy to take any questions before we move into like a brief overview of Git.
Yeah, I had some questions on the these last couple slides you went over, the last couple of examples.
Yeah.
Is there like a way that you could is there like classes you could have for SVG, so you can just say class equals whatever and it always paints them as still blue?
Yes, you can do that.
Okay.
So you can do that just with, like, I can actually write a class attribute here. So that works. I don't have any styling specified now, right? But this works, and you can use exactly, this is going to be super useful. You're going to use this a ton. This is like, if I had, let's say this were my scatter plot, I could actually say ID my scatter plot, right? And then I would have this one scatter plot that I want to render. it's all contained in that element, and so I can do anything that I want to that scatterplot with CSS. Or later, if I want to just programmatically access the elements in that scatterplot, I would actually say, give me like D3 select my scatterplot, and then I have the elements in that scatterplot.
And then a second question is, if you go down to the last example you did about Australia,
Yep.
could you apply transform again inside of text to flip it again? Like if you did inside the text tag, could you say transform equals scale and then do the
Yes.
exact same thing?
You could.
And
so let's see what this does. That should work. I'm kind of like missing the code here. So yeah, but it's gone off somewhere. So you have to be careful of like what you're like where you're positioning it. That kind of like whenever you start rotating, like you might actually be like somewhere off screen. And so that's kind of like what it's tricky, but you could do that, yes.
great, thank you. That's it.
Okay, so make sure to kind of like, this is important to understand because we'll later do like generate this kind of code. And so if anything is unclear about that, just like review this page. I've tried to really also make it usable offline, that you can just read it on your own, and provided lots of links so you can kind of go in depth if you want to. Okay, so the last piece here isn't all that important to the immediate next homework. It's more about like essentially just general purpose good software engineering practice. I want to talk a little bit about version control. I'm sure that like most people have some experience, especially those that are in a traditional CS track. You should have seen about like version control in classes like 3500 or even earlier. But in any case, I'm just going to give a brief overview because we'll be using Git to publish the homeworks. I'll show you. I'll probably not explain it because I don't have a lot of time left. But at the very end here is like a nice way of how you can deal with homeworks in this class, and how you can actually kind of like get updates to homeworks and save your homeworks on here. Get your updates to homeworks and save your homeworks on a GitHub repository, on a private GitHub repository. So if you've done Git before, take a look at this particular section, how you could manage your homeworks, a suggestion. But generally, I also want to give a little bit of an idea what version control is and why we care. So in version control, like why do we want to use version control? Well, we want to be like version control is all about managing code. And code typically, like if you're a single developer working on a project, it's fine. You still should use version control, but you could just use your files in like a folder and work on that. But whenever you start to collaborate, or when you ever want to try to create different states of files, then version control really comes in handy. But it's really like about creating alternative states and collaborating in teams is why you need version control. And so even in a group project, we want you to like put your group project on GitHub, and we also want you to use what's called GitHub pages to publish your group project. And so you will need all of the stuff that I'm talking about here at the latest for your project. One other thing that is great about using version control, especially with a server, is that it keeps your work safe, and it keeps it stored in the cloud. Like your computer gets stolen, your hard drive breaks, your code is still safe because it's stored on a server like on GitHub. And then if you are actually like interested in like developing code that you want to share, like maybe as an open source project, using version control tools like Git and GitHub is the right way to share it. But you can also not only to make it available for download, but you can actually get people to contribute, and you can like have managed development process and how you integrate contributions from other people with something like GitHub. And so there's kind of like two types of version control. There's like the whole centralized repository idea, which is this classic client server model where you have like one server stores the code and all of the version, and then everybody else, the blue nodes here, are like individual clients that write to that server. And that's kind of like the traditional model that you've heard of with CVS and SVN and so on. And this is simple to set up, and it's the decent solution for smaller projects. But it gets complex for larger projects, and especially for distributed projects like open source projects. And that's why, for example, Linux never did something like that, because it's such a distributed project. And it's difficult for community projects. So for example, to be allowed to write to that server, that's kind of like a security problem, right? How do you like apply changes that somebody outside of your team made? And so there isn't really like an elegant way to do this. There's patches and so on, but there is not really an elegant way to do this with a central repository. A distributed version control system is what Git is, or Mercurial. Here, like everybody has essentially like a history of their repository locally. And every node is equal, conceptually at least. So there's no dedicated server. You have your own full-grown like version control server on your local machine. In practice, it's often semantically useful to distinguish between servers and clients. And so though that is not required by a distributed version control system, you can think of like the green nodes here of being two servers and the blue nodes being like people that work on their client and they change the code. And so what's great about this is you don't have access issues. You can just like clone a repository or make a copy of it, hack away, and then contribute, like commit locally to your repository. And then you can say, hey, I've made those changes. Do you want to like accept my changes? And then they can pull it onto their computer. And maybe somebody can pull it onto the server. And then it's kind of like the consensus version in some way. This has other benefits, like since you do a lot of the management locally, not over an internet connection, you do it, it's pretty fast and you don't need an internet connection to require. And what it also can support is this commit often model. So when you write software, you should actually try to do an atomic change, like a semantically meaningful change, and then commit that. But you don't need to kind of like write that to the centralized repository, right? You rather, like you actually don't want to do that. You want to make like 5 or 6 of changes, and then merging it into a central repository might involve some testing and so on, and that might be time consuming. And so this allows you to commit often and then later sync it with a centralized server when you're ready to do so. The cons of distributed version control is that it's a pretty complex principle, and it's also Git itself is fairly complex. And there's some extra effort involved between differences between committing and pushing and pulling, synchronizing, and so on. So there's a couple of different implementations. The centralized ones are CVS and SVN. The distributed ones are Git and Mercurial. But will be like Git is kind of like becoming the dominant force for like the last 10 years, maybe. Git was created by Linus Torvalds, the creator of Linux, in 2005. And the meaning that he gave, he's kind of like a weird guy. He used a British English slang term, which is roughly equivalent to an unpleasant person. And he actually said, I'm an egotistical bastard. I name all my projects after myself, first Linux, now Git. So why do we care about Git? Because it's kind of like the default standard for open source project nowadays. It's also very popular in industry. It is truly distributed. It's very fast. Everything is local. It's free. It is also safe against corruptions. And last but not least, actually, GitHub is also like a great platform to share code, and GitHub is all based on Git. There are some downsides. It's fairly complex. And so this is kind of why there's a little bit of an introduction here. So note that we are running out of time officially. So like, if you've seen this before, or if you like have something else to do, just like sign off, take a look at this, or look at the video. But I'm gonna keep going for 10 more minutes. But this isn't considered official class time. Think of this as like a Git tutorial. So I'm not gonna take an offense if you kind of want to sign off since our class time is over. Okay. So for those that are still here, I wanted to briefly show how Git works conceptually. And to do that, I want to share a sketch with you that I would usually do on a whiteboard, but let's see how well that works on my iPad. So yeah, so you should be able to see my screen now, my iPad screen. Okay, so let's suppose I'm starting out a new project. Okay, so I'm going to draw here like a line that kind of distinguishes between two different systems. And I'm starting my new project by going to GitHub and clicking on new project. And so what happens on GitHub, like this is GitHub. I have now created a Git repository, like an empty repository that has nothing in it. Okay, and then here's my personal computer. And now I run a clone command. So git clone whatever. Now I'm creating a copy of that like empty repository on my local screen. Okay, and now I start hacking away. I write code, and this code essentially then creates a new version. So now I have like here a local version that is different from the version on the GitHub server. This is like, I actually commit this to my local repository. This is like a local Git repository that uses the same technology as GitHub does on its server, but I don't have to synchronize it immediately. So this isn't something that I have to push to that server immediately. You can then hack away and do another like commit and maybe another one. Now I've created 3 commits. And now I kind of like feel like, hey, I'm done for the day. I want to save my work to the server. And so what I'm doing now is I'm explicitly pushing this to the GitHub server. And what happens now is that GitHub on its server actually recreates the whole status as I had it on my local repository, right? So now those two are perfectly synchronized. So now let's suppose I have like created an interesting project and I'm working with my classmate on this project. And so now they might come in as like my friend, and your friend might now say, hey, like I'm gonna like take this and copy it to my computer by running a clone command. And then I'm gonna make a change. And I'm gonna make another change. And now I'm moving this back to Git again, to GitHub again, to like the central server. And what happens is that GitHub again recreates what I've done here before. So now, like in the meantime, you at your computer have created another version. So you have worked on this project simultaneously. So those 2 commits here, they are kind of more or less in conflict with each other, right? And so now if my personal one, if I want to go back to and synchronize this with the server, if I try to sync it here, it won't let me. So it will say, hey, you don't have the latest version. So what you have to do first is you have to kind of like pull these changes. Let's see how we represent this. You pull these changes, and then you get like a hybrid state here. And that hybrid state will potentially have conflicts that you have to manually resolve. And so you manually resolve these conflicts, create a new state, and then you synchronize it back to the GitHub server. And then your friend can get your changes by synchronizing it back to the GitHub server. And so that's roughly how this whole principle works. And this is very similar. Like this is now, I've talked you through this with 2 different users and the server, but you could also, this is exactly the same applies if you just have multiple branches on your local computer. So any questions about this before I switch back to the computer? Okay. Great. So, and like now I'm going to just walk you through a couple of these quick Git things here. So first, like in the following, I'm using this $ symbol to signify a prompt in the command line. So here, I'll run this with my command line. So I have like a %, but this is kind of like the same thing. And so whenever you want to copy something like that, you don't need to copy the $. This is just to distinguish it from output. which doesn't have a leading symbol. So first, you should configure your Git. If you haven't already, you should put in your name and your email address. And if you work on like a class project, you should put in your official Utah email address here so that like this is all like nice and proper. Okay, now I'm gonna do this live. I'm gonna create like a Git repository locally, and then I'm gonna do some things to it. I'm gonna do some branching. Eventually, I'm gonna synchronize it to GitHub. Okay, I'm starting off with making a directory, my project, and then changing into my project. And then here I'm doing git init, which initializes an empty repository. So now we can see if you just list what's going on here, we don't actually see anything, but we see some hidden files. So we see this .git is a hidden folder. So if we look at what is in this .git folder, we can see there's a couple of folders, but the most important thing is actually in that config file here. And so here's like the simple example of a repository that you just created. Here's a more complicated example of like if I had, this is how Git stores where are different destinations. So here would be the remote origin is the GitHub server where this comes from. And then if you have multiple branches, all of this is stored in here as well. This is just an FYI. If you ever screw up a Git repository, you can look in here whether there's like to understand what's going on. So now let's create a file. Echo simply puts out something to the console, hello world, and then I can pipe that into the file demo.txt, which doesn't yet exist. And so if I do that, we'll see that I have now created a demo.txt file here. And I can see what is in that demo.txt file. Cat simply writes the content of the text file to the console. And so like now I've created a file, and now I have to actually add it to manually to version control. I can say git add demo.txt. And so now this hasn't changed anything. But if I run git status now, I can see that there are no commits yet. I have one change that is like not yet committed, but that Git knows there's a file demo.txt coming. And so if I want to commit that file, I would say git commit -m committing the test file. Okay, and now this file has been written to the version control repository locally on my computer. What I did here is that -m is the commit message. If I don't do that, it will drop me to an editor to provide a commit message. And generally, you should write meaningful commit messages. If we now check the status of Git, we can see that we are on branch master. There's nothing to commit. Working tree is clean. So now if we change that file again, if we say echo, are you still spinning? And the two symbols here say that they should be this should be appended to the file, not replaced. If I did a single one, I would replace it. And now if I look at demo.txt, I see that I have both lines in here. And now if I run git status, I can see that demo.txt was modified. And so what I could do now is I could say git commit -m added a line, but this is actually like not doing anything because this is kind of one of those weird Git idiosyncrasies. This is kind of like I've changed it, but not explicitly said I wanted to commit it. And so virtually always do you do something like git commit -a, and this means add everything that has been changed -m and then added a line. So now I'm actually saying all of the files that you've already like taken a look at or that are already registered, all of the changes that are made committed to those files, just like add them to Git and then commit that. That doesn't work for a new file. So if you add a new file, you have to explicitly add it. So this the -a flag doesn't do that. So now I have actually successfully committed it. If I look at the log, I can see that like what has gone on, like what has happened with this repository. I have two different commits. Okay, now similar to what we do if we have different servers or different computers, we can just work with different branches. And different branches are useful because we might want to like try out something without changing what we originally had. And I created draft branch, and draft here is just a name. It can be anything by saying git branch name. And now if I look at git branch now, what are the different branches? I can see there's a master and a draft branch, and the master has kind of like a star symbol indicating that this is the active branch. So, and then I can switch branches by saying git checkout draft. So now I've switched to branch draft, and the draft branch is now the same thing. I have still my demo.txt, which looks exactly the same thing. But now let's edit it a little bit more and say echo spinning round and round, and then adding this to demo.txt. And then if I like, well, it is in there. But now if I commit, git commit minus m spinning. Okay, now that worked. So these branches are now in the draft branch, but the master branch is unchanged. So I can do git checkout master. Now I'm back on the master branch, and if I look at demo.txt, then I see that the line that I just wrote here, it's not in here. And so now I could just merge those two, and that would work fine because the master has remained exchanged. But I'm gonna do something. I'm gonna cause a conflict. I'm gonna say echo yes, I'm still spinning, and append that to my demo.txt file. Then commit that, creating conflict. And now I have like two different versions of that file. And if I now try to merge the draft into my master, then I get this merge conflict information here. So it says automatic merge failed. I have to actually manually fix that. And if I do that, I can open demo.txt. And now you can see that I have like this symbols here. This is my head. And so I kind of have to resolve the conflict. I could simply just do that by removing these commands. And then I would have to create a new git commit, a new commit to to resolve the conflict. Okay, the result here is that I now have kind of like resolved the conflict, and that works exactly the same if I were to do this for like between like a server. Okay, so let me think. Maybe I guess we should wrap this up. I think the rest here is fairly self-study. I just want to point out, yeah, take a look if you haven't seen that. I might just also do follow up a little bit more in another lecture when we have a little time, and wrap this up with GitHub, because it can be useful, especially for your project, but it's not super urgent to do that. So I'm going to take a couple of questions, and then I'll have office hours at 2 if you want to talk about something more one-on-one.